So for those who know me, I am Steve Frazier. I'm an engineer by training. An old I just kind of working in semi-retirement now and doing some consulting work. One of my old managers reached out to me to help him with a project regarding a private Christian school that was having some challenges with enrollment and selectivity for students. They were concerned about it. So this gave me an opportunity to take some of those 40 years in manufacturing where we did a lot of modeling and did a lot of testing, a lot of building and designing, and see what we could do to see if we could uncover uh, some things that they needed to help solve their or deal with their problems. Let me begin by stating that my client prefers to maintain their anonymity along with their students and competitors. However, I think there's enough information here remaining, even beyond that, that you'll be able to, one, if you really want to dig, you can figure out who they are, which I hope you don't. And two, but you'll be able to see some applications of where I was able to use Bayesialab and Hellixia to help them generate some insights and information about their challenges. And I used all Bayesialab. Okay. All right. Yes, I'm safe. So this is an independent, private K through 12 institution where their applications have kind of plateaued, right? Coming out of COVID, that's probably not unexpected. Okay. Um, the other challenge is that they are seeing some issues with family migration and commute burdens. Okay. So this is Atlanta. This map you're looking at right now is Atlanta. And let me see if I can show, let's see if I can show you here on this. Point laser. So our school is right here in the middle of the screen here. Um, and all these little blue dots that you're seeing on here, these are their students. So you can see their students are coming in from significant different distances in the morning and leaving in the afternoon. Um, all these other little dots that you're looking around are some of their major competitive schools surrounding them. One of the things, so what the leadership was trying to figure out was what's going on around enrollment, what are the factors that are driving it, and what could they do to affect it. They also have a unique Gen AI tool that they use with their students to try to improve their academic performance. Now, it's still in its newest stages, but they also wanted to sit down and see how that was performing with their students. And so let me go back here real quick. And so we did a couple of different analyses here. I thought that we could use Alexia to understand the factors um, that would be helpful in guiding the analysis. And so what we looked at were Hellixia causal models to identify the drivers of enrollment and also identify the analytical touch points. So what things do we need to be looking at? And then I use the semantic models to analyze the student chats with their Gen AI tool to see if I could understand if there were some challenges with their tool that they could address that might help them improve that as well. Um, and so let me see here. Okay. So what you're looking at the bottom here, I initially developed a causal model in Hellixia because I wanted to sit down and figure out what those drivers were, drivers of enrollment and selectivity. And at the same time, I used the bow tie model that is that Lionel's pretty famous for, where I could look at triggers and controls, look at latent factors falling beneath here that you'll see here, down in this range, and then our target, and then look at consequences, which are these bottom nodes at the bottom, and mitigating factors. So I wanted to look at a full causal type of model to sit down and look at all the things that were possibly available to them in terms of getting insights and addressing the problems. These two models that you're looking at here are actually the semantic models that we use to analyze their chats. So we went through about 59,000 chats. And there were about 1,100 students to try to analyze what the kids were saying and when they were trying to use the tool. And that's where we started there. So what we were trying to understand is why are applications declining beyond 20 minutes? And this 20 minutes really represents, let me go back. I want to see this. If you look at this ring here, in the morning commute, this is probably about a 20-minute commute to get into the school in the morning. And this outer ring is about a 40-minute commute. And what we find is that once you go past 20 minutes, enrollment starts to drop off drastically, and applications do as well. So I wanted you to see that. So in the causal model, these are showing you snippets of the causal model that are talking about latent factors that were identified and their actual factors here so that we could do some analysis, that we could look at for analysis. And a couple of things came out of that. We learned that enrollment probability drops about 25% for every 5-minute increase beyond a 20-minute commute in the morning. So once you go past 20 minutes, every 5 minutes, bang, we start seeing less and less people, which is what you would expect to see a decline, because that's what you should see. And then the other thing we noticed was that there are high income clusters that are actually out of reach for the school. In other words, they're so far out, and then there's a lot of competition in the way. So they're challenged by the competition of other schools and the fact that there are clusters of high incomes that are not available to them. And so transportation, tuition, aid distribution, and digital engagement were identified as latent factors. So enrollment probability drops by 25%. So here's the data that justifies that. So when we built the causal model, it brought that up, that enrollment drops. And I needed to figure out I wanted to justify that. I wanted to see the analysis on that. So one of the things I did was took every student's home address using Google Maps and calculated the distance from their house to the school, how long it was going to take them in the morning and in the afternoon, so that you could have real numbers. Now, we did use your famous Haversing analysis in some of the modeling work as well, but I wanted to at least see what the real numbers were. And so you can see it right off. This top chart shows their total commute minutes, so which is basically to and from school. And you can see that the number of students, after about 25 minutes in total commute, it begins to start to drop off, right? And similarly, you can also see this is commute miles, I apologize, and this is total commute minutes. So after about 40 minutes, it starts to drop off, and it's dropping off about 25% for every few minutes or more than that, or actually not that much, but it's dropping off quite a bit. And so one of the things that we wanted to do after that, we wanted to talk about the income problem. So we looked at that two different ways. The first chart here is a census tract plot on the left. So you can go in and get government data, and you can basically capture median incomes by census tract around the area of the school. And so what you see is these these areas are higher incomes. And you'll notice our school is here, right? And you'll notice all these competitive schools kind of forming kind of like locking out. So you're losing access to all these schools because they're all falling in the ring outside the 20 minutes, right? So that's a challenge for them. And then you'll notice as you drive out east from the school, these are the lower incomes. So that's one of the things we were able to, that was coming up in the causal model. And then we were able to see that when we started getting the government data. The other thing I looked at was the Zillow Home Value Index. In other words, I took each student's home address and basically got an estimate of their home value, which I use as a proxy for household income. So you can kind of so what you're looking at in the second plot here on the right, the colors represent kind of like the student's home value. And you can see that the reds are the lower home values, and these other clusters in the gold and the orange and the yellow are the higher home values. So these maps kind of followed each other. So it kind of, again, verified that what we were seeing is that going to the east, you're seeing lower home values, lower incomes, where they had access, but not a lot of competition. And going to the west, you had more competition, and that's where but you didn't have the reach. You were outside the reach. Tuition aid. One of the ways that you can increase the selectivity around students is where you can provide tuition assistance. So that was brought up in our causal model as well. So what does that look like? Well, and you can see that the causal model, I took the snippet and shows it right here on the far hand. That was in our causal model that we developed. And what you're looking at are the students that are receiving tuition assistance. And that's about 36% of the kids are receiving some form of tuition aid in the school. Um, that ranges from just under $10,000 all the way up to 25,000. So I guess you guys aren't blinking because I guess you're seeing how high it costs. This is high school, right? We're talking about elementary school, high schools, where we're talking 25 to $35,000 a year. That's college tuitions, literally. But that's what people are spending nowadays for their kids to go to these types of schools. And you can see that there's not a real issue in terms of what they're doing, in terms of the distribution of financial aid, how they're paying, how it's going out, and what they're granting to students. And it's also a very powerful tool for allowing you to generate, improve your selectivity, particularly for disadvantaged students. So again, if you're looking at the causal chain, you're looking at commute distance, household income, financial aid, academic performance, probability. And you can see in our model that we're showing that inadequate transportation solutions is one latent factor. We're also looking at inadequate financial aid strategy. And those are not showing up as inadequate financial aid strategy in terms of the prior probability is not showing up as a problem. That's what the model was saying, and we just validated that with the data. What the challenge is around transportation. And I'll get into that in a minute, explain why that is. Then the other challenge was with the Gen AI program. And I call this learning from the student voice. So I went through, and what we did was we had 59,000 chats, where the kids are talking to the computer and they're going, oh my God, this is not working, or help me understand this. About 1,189 students. And the problem was this is a myriad of courses, English, statistics, math, blah, blah, blah. So we're trying to figure out how to separate this out into what category. So we broke it up into two themes, procedural and then conceptual analytical. So procedural learning, is basically subject that emphasize methods, practices, and structured processes. So that's your math and science, right? And then the conceptual analytical courses are subjects emphasizing reasoning, interpretation, and critical thinking. And then, Lionel, you've got so many keywords, I can't keep up with it. So I had to use ChatGPT. I hate to say I use it quite a bit. He has 165 keywords. I'm trying to build a semantic model. Oh, great, thanks. I don't have that version. Drive. So what I did was I went to ChatGPT and said, look, I'm trying to understand challenges and possible deficiencies in a Gen AI model. Take these 165 keywords, select the 3 or so that would allow me to get that diagnostic. And so the keywords that selected were issues, questions, and examples. And the reason, the cluster is confusion and uncertainty, again, request for support, and then the diagnostic meaning is here, where it indicates a student perceives something as unclear or problematic, or represents uncertainty of a knowledge gap, or suggests that learning needs scaffolding or a model to understand. And so from that, we generated 2 models, semantic models. So the model on the left, this is the model that was related to conceptual analytical challenges. And then the model on the right, this is the one that was related to procedural and learning based. So this is a summary of those 59,000 chats. And trust me, I used up all 1 million of my tokens trying to do this. Because ChatGPT, once you get over 1 million tokens, it goes, right? So you can't, but I was able to get that and extract enough information that there were some opportunities that were identified, okay? And so so what I did was I went back to the causal modeling again and said, what does a causal model look like for a Gen AI-based academic program? How does that what are the properties of that model? What are the attributes of that model that are going to make it successful? And so it basically said kind of like a base model, because Lionel's talked about this in one of his presentations about taking the model complexity up. The base model is really the themes are focused on feedback, engagement, and curriculum alignment. And so kind of where we're at with the AI tool we have now is at this base level. So then I took this model, took it to the medium complexity, right? And then took it one more step to high complexity. Now, I'm looking at these things and I'm going, what's the difference? Well, what I did was I put them in ChatGPT. Simple. Read the models, and actually it can read the models in Hellixia. I've been doing that for a while. And it said our base model, the core focus is on foundational causality. The key features are feedback, curriculum alignment, and teacher support. And that if you're going to be working with this model, you need to build reliable real-time feedback loops. That's where you're at the base level. Now, when you went to the medium model, what was the difference? The core focus is on adaptive responsiveness. So what happens is you're starting to personalize this thing and provide emotional support, because some of the kids were literally screaming in their chats at the responses they were getting from the model. They were struggling with it. And so the next step would be emotional support, continuous monitoring. And then that's when you focus on working with training educators and integrating the model into the learning curriculum. Okay? So that would be the next phase of the model if we're going to take it to the next step. And then when you took the very complex model, it came up with the term synergistic ecosystem. So now you get into what they call co-adaptive learning, predictive analytics, and multi-agent feedback. It's almost agentic, because at that point, the tool is actually working with the student, the parents, and the teachers to help the student to actually, it's more, instead of responding, it's trying to do more interventions to help keep the student on track. So in one way, what the causal modeling did was it actually showed us kind of like the steps that your Gen AI are going to have to go if you're going to make these tools work for students. Okay. The other thing we noticed with this was that we found that students who read well tend to can work at the base level. So reading proficiency, writing proficiency, those things, you're advantaged. So if you come from a good socioeconomic background where you've been exposed to this stuff, you've been using computers for a while, or if you're in a private school where you're in an environment where a lot of kids are like that, then the base model will probably be very successful. The challenge will be in public schools, because public schools, they don't have that. So that's one of the things that the school wanted to do, was explore the possibility of exporting this to public schools and other systems. And that might be a challenge. So unless they can improve some of the characteristics in the model. The other thing was the model was released in fall of 2023. So the problem is that we have, I call them cohorts. So we don't have a lot of evidence right now to show whether the Gen AI tool is actually driving performance. We see improvement in ERB test scores. And so what we did is I broke them up into cohorts. So this cohort number 7 that was in the 5th grade in 2022, and then they were in the 6th grade in 2023 is when the model was released. This cohort right now is showing at the bottom some areas of improvement on ERB testing. I can't show you the numbers, but they are. So we're trying to figure out, okay, is that the model? Is that the Gen AI? Is it just kids get better? But we need to figure out how to analyze that to be able to understand what the direct effect is of Gen AI on student in adding. So we have some work to do that we're going to do there. So again, go back to ChatGPT, my favorite tool. Tell me what I got to study. What variables do I need to collect? What information do I need to capture in order to build long-term a BN model so that I can calculate the direct effect of the Gen AI tool on student performance? And this is the kind of the list that I've got. It explains the type, whether it's observed or latent. It explains example indicators of data that you need to capture, the transformation method, and even examples of states. and then parent notes. But this is something that we're going to be looking at going forward with next as we go back to cohort number 7, because we think that cohort number 7 will be one of the first ones that will have been exposed to the tool for at least 3 years, and they are already showing some progression in their scores. So the other thing I want to go back to is this transportation issue. There was some belief that we had about 307 students out of around 1,700 that were actually riding the bus to school, but they weren't riding the bus every day. And when you calculated it to full-time equivalents, it was more like maybe 85 students. So what's going on here? And the belief was that parents just wanted the bus as a backup plan. In other words, I can't get Johnny to school today. I can stick him on the bus. He can get to school. And that's how they were thinking. But our causal model wasn't saying that. Our causal model was saying different. The presence of a bus really has an impact on applications. I mean, a fully functional bus. But what's the problem? So I did a little analysis again. So here's what's going on. These little red dots right here, these are the stops where we're picking up the kids. Notice where the stops are. They're following Interstate 85, coming down here, and then over here. Look at all the students out here that aren't even near the bus to get picked up, right? And if you do a distribution on that, you'll find that in some cases, you've got students that are as far as 12 miles away from the closest stop. So that's not really very attractive if you're a parent, knowing I'm going to drive 12 miles to get to the stop for my kid to go to school. So that was my pushback. And I said, maybe we need to look at that. Also, you have to look at bus usage by grade. So if you look at most of the bus usage kicks in around 6th grade. So the first K through 5, it's not a lot of kids riding the bus. After 6th grade, it picks up. So knowing that, the school came back and asked me, well, can you figure out how to reconfigure our bus stops so that we can get the kids? Okay. So that's going back to my favorite tool, ChatGPT, I came up with bus stops and loops. So basically saying, okay, the colors represent a loop. You pick up kids here, here, and here, and then you head into school. All right. You pick up these green ones here, here, and here to head into school. It's all using cluster analysis. It's not rocket science. All right. But the big factor is look at the change in the distribution. Almost 1,000 kids are within a mile of a stop versus what you had before. You're going, and nobody went out really further than a few miles, and certainly not 12 miles. So I'm trying to make the argument that maybe you guys need to reconsider how you're looking at transportation if you really want people to, because remember, if you want to ride the bus full time every year, that's another $3,000. So who's going to pay $3,000 possibly for, again, to ride to go 12 miles? It's not going to happen to go drive for 12 miles to pick up their kid. So that was something that we need to look at in terms of changing our thinking about how we lay out stops and how we get the kids. So finally, what did all this net out to be? Then the final question was, well, Steve, what recommendations would you have for us? Because maybe we want to build some feeder schools and some hub schools. So a feeder school would be like a small K-5 school, right? And then we'd have a hub school, which would be a K-12 school. So what I thought about it for a while and said, all right, these red dots right here is where I would think you would want to place feeder schools. In other words, they're right on the 40-minute mark, okay? The ring that you were talking about here. And there are 4 of them because they were looking at 4 schools. And then we were looking at a hub school further out east. So the idea was with these rings based upon Haversian analysis and figuring out what we could locate some schools, but then that also brought up another question. The current campus is K-12. If we put feeder schools in, does the current campus become 9-12 or 6-12? you know? So it's possible now. We had to go through some additional modeling, and I can't show you that, but what we've done now is we've said that's going to change the campus because the feeder schools could actually provide the students into the main campus. And you can set up, if you have adequate bus transportation, you could make that work. So in some ways, it raised a lot of new questions and some things to think about. But at the same time, like I said, it may allow them to increase their attendance to over 2,400 from where they're at today, which is like be another 700 students long term. So Hellixia enabled us to replace intuition with inference to see why outcomes occur, not just where, and to translate complex probabilities into board decisions. And the expression is families don't just enroll, they invest in proximity and trust. So, any questions?